So last week we talked all about patterns with correlations and causations and lines of best fit. So this week we are doing something similar where we are still talking about patterns, but it looks a little bit different from how we did it last week. So what we're doing this week is something called linear sequences, so arithmetic sequences, and it's pretty easy, not too difficult at all. So what we have in the first question is that we see a pattern between shape 1, 2, and 3. So I want you to take a second and take a look at those boxes and see if you can figure out what this pattern is for these first shapes here. So what we can see is that we know that they are adding boxes each time. So in each shape, they're adding more boxes to them. So in the next question, it says, using the pattern, draw the next two figures. So the figure looks like an X with this little box in the middle. The first one had one box on each side. The second one had two boxes going off of the middle. And the third one had three boxes going off of that middle box. So what this means is that the next one from my middle box, if this one had three going from each side, it means I need four. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay? So that's the next one. So if we have a one box off of its side, then two from the side, then three from the side. We just drew four from each side. So the next figure is going to have 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Good enough. Okay, so from my pattern, I'm adding an additional box on each side. So now if we looked at the first figure, and if we were to count how many total boxes are in figure 1, we would end up with the fact that there are 5 squares, 5 boxes. Let me make that a little bit smaller. So there's 5 in the first one. So then in the next one, if you were to count them, 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 in the next one. And if you were to count figure 3, there are 13 there. Then we just drew figure 4, and there are 17 squares in that one. And then we drew figure 5, and there are 21 squares. So what we have here is a pattern starting from our first figure all the way to our 5th figure, and we were just adding boxes. We were looking at a pattern where it added boxes on each side. So now it says, can you continue the table without drawing more figures? So what we're going to do is take a look at this table. So to get from a 5 to a 9, what did we do? We add 4. To get from 9 to 13, we add 4. 13 to 17, add 4. 17 to 21, add 4. So that means that in figure 6, if we were to add 4 to our 21 that we had, we would end up with 25 squares. And then in figure 7, we would add another 4, and we'd end up with 29. So we made a sequence, a pattern of numbers by adding 4 to each one of those boxes. So in each shape, we had our original one, and then they added 4 boxes every time. Okay? So I want you to try the same thing with number 2. So in number 2, you're going to describe what you see. No wrong answer, just to tell us what the pattern is that you see. Then using the pattern, you're going to draw the next 2 figures, put those numbers of circles onto a table, and then predict how many circles are in figure 6 and in figure 7. Okay, go ahead and try that there. Okay, so what these patterns are called sequences, and we have a number and we're adding more numbers to it. It's something called a sequence, and this one it is an arithmetic sequence. So what that means is that this is a pattern where we add or subtract. So in algebra, if you see a pattern that we are adding or subtracting, that's called an arithmetic sequence. So the common difference is the number you are adding or subtracting by. Okay, so common difference. So let's look at number 9. So it says, is this an arithmetic sequence? Let's check. To get from an 8 to a 10, we add 2. 10 to 12, add 2. 12 to 14, add 2. 14 to 16, add 2. So yes, this is a sequence because we are adding 2 to every number. So that's my common difference. So go ahead and try the same thing with number 10. Is there a pattern? A pattern of adding means it's called an arithmetic sequence. And if there is a pattern, write down what that pattern was. Let's try the same with number 11. Number 11, from an 18 to a 16, we subtract 2. From a 16 to a 12, we subtract 4. From a 12 to an 8, we subtract another 4. So when I look at this pattern, no, it's not the same number that's added or subtracted each time. So no, there is no common difference because we're not adding or subtracting by the same number each time. In this one, we were good, yeah, because it was plus 2, plus 2, plus 2. This is not good because it's minus 2 and then minus 4 and then minus. Not the same. So this one is not an arithmetic sequence. So this is not. Okay, try the same thing with number 12. Yes or no? If so, what is the common difference? Okay, so now we are going to use these tables to use the sequence formula to write the equation of the pattern that we have here. So just so you guys know, this was just a unit that would have been on a STAR test. So that's why we are going over it to make sure that we covered all of the objectives of Algebra 1. So this is connected into writing equations, which we will talk a little bit more about in the next video. So in this video, what we need to know is to write the equation of a sequence. We start by finding our common difference. So we just said the common difference is the number that we are adding or subtracting by. So that's the number it's changing by, which we call the slope. We've talked about slope before. The slope is how much it's changing. So this number right here, that's going to go in front, is the common difference. Then we have the letter n, which is our input. We call that the variable. It's usually an x, but in this one it's an n, which will make sense in a minute, I promise. And then it wants you to take your first a value. So a1 is just your first y value. First y value. Okay? So what we have from this table, to get the common difference, I need to figure out what they are doing for the pattern for each of these numbers. So from 13 to 16, we are adding 3. Then again, plus 3. Then again, plus 3. So the common difference, so my equation is an, my sequence, is that we are adding 3, and we have parentheses, and minus 1 can stay. And then we have plus our a1. Our a1 is the first y value. So our first y value is plus 13. Okay, so this is my number. So what this means is I could take any number. So say I wanted to know what 6 was. I could plug in the number 6, plug it into this equation, and figure out what the output number would be. So we are writing the equation from this table using the sequence formula. In the next video, we will distribute and combine like terms, but in this one, we're just going to keep it like so. So go ahead and try the same thing with number 14. So in number 14, you'll just write an, that's my sequence. I need to know what the common difference is. Then n minus 1 is just part of the formula. And then I need to know what the first y value is. Okay, so try number 14. Let's try another one together, number 15. I'm writing the equation of the sequence. So first I need the changing number, the common difference, also called the slope, if we were doing this from a regular linear equation. So from a 9 to a 5, we are subtracting 4. So I'm going to put minus 4. My variable n just gets to stay in the equation, n minus 1. And then I have my first a value. My a1 And in this one, my first A is my Y. It says A1 is your first Y value. That's what it says. So this here is plus 9. So that is the equation for this sequence. This is the equation for the pattern. So I could plug in any number for n. So if these were shapes, like in the first shape, there are 9 boxes. In the next shape, there are 5 boxes. And the next, there's only 1, and then -3, and then -7. So this equation would tell you how many boxes are in the 10th shape, or the 11th, the 12th. So we're just writing the equation using the sequence formula. So go ahead and try the same thing with number 16. All right, next one. Last few here. So now it says make a table for the values for each sequence, then write the equation to represent the pattern. So it's the same thing. So what we were saying is that we're listing in order. The first number is a 32. So they're calling it, instead of calling it X and Y, they're calling it your number and your sequence number. So the first number is a 32. The second number is 22. The third number is 12. The fourth number is 2. So that's the table, done, table of values. Then it says write the equation. The equation is this. My sequence is my common difference times n minus 1 plus my first y value. Okay, so the common difference here, each one we are subtracting 10. Then we have a number minus 1 plus my first y value, which is a 32. So this is called a sequence that would tell you any number in the sequence. So if I wanted to know what the 10th number was in the sequence, I would plug in a 10, I would calculate this, and I could tell you what the 10th number in this sequence is. Let's try one more. You try 18, and then I'll show you 19. Okay, number 19, the first number in my pattern is a -15. My second number is -13. My third number is -11. My fourth number is -9. So I need to write down the pattern equation. We start with our common difference. To get from a -15 to a -13, negatives can be a little bit difficult, but they are, from -15 to -13, they are 2 units away. We are increasing 2. Then we end up with n minus 1, and then my first y value is -15. So this is the equation that would tell you any number in this pattern you would plug in for n. So if I wanted to know the 20th number on this list, you would plug in a 20, and then you would plug this in, calculate, and you'd figure out what the 20th number in the pattern is. Okay, last one, go ahead and try number 20. I'll give you a hint. If we're at 7, and we need to get all the way down to -2, it is 9 units apart. So in number 20, I know integers can be a little bit more difficult. So from a 7 to a -2, that's 9 units. We're subtracting 9. Okay, so that is it for video notes 1. Nice and easy, 20 questions. Video notes 2 is even shorter and even easier in my opinion. So when you're ready, go ahead and jump on over to video notes 2, and then you are done with this week of instruction. Thank you.